Welcome back students to your SST class, and we have completed with our history chapter number 1, so it's time to go further for geography chapter number 1. So the lesson of your geography chapter 1 is the earth and the graticule, which you'll be able to see on your screen right now. So this chapter needs a globe, a map, some geometrical instruments. So for this, only explanation is not enough. You'll have to see the constructions and everything detailedly with the instruments, so that you will need a proper video with all the necessary equipments. So here's the video on geography. It's first chapter, the earth and the graticule. So I want you all to look it very carefully. Each and every detail is been given in the video, and then same way after finishing the chapters explanation, we will also cover the exercise, so that even our first chapter will get complete. So let's begin with the video. Watch it very carefully, and then we'll solve the exercise in the next class.
Introduction. To know the precise location of any place on the earth, we require to know the specific directions and extent of that location. The geographers have developed a miniature form of the earth called globe. Though our earth is very large in size, we can find any place using longitudes and latitudes on a map. Let us study using graticule how to determine location of a place on the earth. Explanation. The lengths of the east, west and north, south diameters of the earth. This will give you some idea about the size of the earth. Oceanic waters, uneven nature of the land, forests, innumerable islands of different sizes and buildings make it impossible to actually draw such lines on the earth. In order to overcome this difficulty, geographers developed a miniature model of the earth in the form of a globe. This can be used to determine location on the earth. One can actually draw horizontal and vertical lines on a globe, though not on the earth. Thus, they are imaginary lines on the earth. Angular distance. The location of any place on the earth is determined with reference to the center of the earth. In order to do it, we consider a straight line joining the point on the surface and the center of the earth. At the center, it makes an angle with the plane of the equator. The measure of this angle is used in determining the locations. For example, in figure, the measure of angle XMV is 30 degrees. That is, its angular distance from the equator is 30 degrees. Figure shows another plane. It passes through X. It is parallel to the plane of the equator. Observe and see how it meets the surface of the earth. Note that it forms a circle on the surface. Any point on this circle and the equatorial plane form an angle of 30 degrees at the center of the earth. Do it yourself. In the upper portion of the circle, at the center X, draw angles of 20 degrees. V1 x K1 and V2 x K2, K1 and K2 being the points on the circle. Draw an ellipse joining K1 and K2. In the lower half of the circle, mark angles of 60 degrees and name the points on the circle as P1 and P2. Draw an ellipse joining P1 and P2. Can you tell? Are the distances between K1, K2 and P1, P2 the same, compare the distances x, k1 and x, p2. Are these distances the same or are they different? Now compare the ellipses you have drawn. Which is the larger ellipse? Why? Explanation. Parallels of latitude. You must have realized that the ellipse drawn by joining the 20-degree points is larger than the ellipse that joins the 60-degree points. However, the distances xk1 and xp2 are the same. This is because we are dealing with a sphere. Note that though these lines appear to be ellipses in the diagram, on the globe they are circles. The circles thus created at some angular distance from the center of the Earth are parallel to one another. Hence, they are called parallels of these latitudes. The values of parallels are angular measures expressed in degrees. The degrees of the parallels are measured from the equator. That is why the equator is considered as 0-degree parallel. It is the largest parallel and also a great circle. The angular distance of other parallels towards north and south goes on increasing away from the equator. It's your brain power. The equator bisects the Earth into north and south parts. The one to the north is called the northern hemisphere, while the one to the south is called the southern hemisphere. Towards the north and south of the equator, parallels of latitude progressively become smaller and smaller. On the globe and also on the Earth, at the north and south ends of the Earth's axis, they appear as points. These are called the North Pole and the South Pole respectively. While mentioning the value of a parallel, it is necessary to mention whether it is in the northern or southern hemisphere. The parallels from the northern hemisphere are referred to as 5-degree north, 15-degree north, 30-degree north, 50-degree north, whereas the parallels to the southern hemisphere are referred to as 5 degrees south, 15 degrees south, 30 degrees south, 50 degrees south. A line joining all the places located to the north of the equator at an angular distance of 30 degree is 30-degree north parallel. Hence, all the places on this parallel will be at the same latitude, which is 30-degree north. New Orleans in North America, Cairo in Africa or Basra, and Lhasa in Asia are all located in 30-degree north parallel. The same concept holds good for all other parallels. One can draw 181 parallels on the Earth at the interval of 1 degree. At 0 degree, that is the equator. 90-degree parallel in the northern hemisphere, 1 degree north to 90 degree north. 90 parallels in the southern hemisphere, 1 degree south to 90 degrees south. Do it yourself. Let the line AM be 0 degree. Draw the line MB, measure the angle it makes with the line AM and write it near B. Note the semicircle that passes through B and joins the north and south poles. Trace it. Now, join MC. Measure angle AMC and write it next to C. Draw a semicircle that passes through C and joins the north and south poles. Draw a line that passes through point A at 0 degree and joins the north and south poles. Explanation. Meridians of longitude. You will realize that the lines drawn from points A, B and C makes angles at N, the center of the Earth on the plane of the equator. Through these points, we can draw semicircles joining both the poles. Starting with point A, we can draw similar semicircles through points placed at each degree. These semicircles are known as meridians of longitude. One of these meridians is considered to be 0 degree. It is known as the prime meridian. The angular distances of the other meridians from the prime meridian are measured in degrees and are called longitudes. The 0 degree and 180 degree meridians lie opposite on the globe, forming a circle. This circle divides the Earth in the eastern and western hemispheres. All meridians are equal in size. Meridians in the eastern hemisphere are labeled as 10 degree east, 25 degree east, 135 degree east, etc. While in the western hemisphere, they are labeled as 10 degree west, 25 degree west, 135 degree west, etc. 30 degree east is the semicircle that joins all places at an angular distance of 30 degree from the prime meridian. Some of them are Cairo, Harare, and Durban in Africa. Though the Earth is huge in size, we can tell the exact location of places on the Earth using latitudes and longitudes. Note that the distance between two adjacent parallels is the same everywhere, but the distance between two adjacent meridians is not the same everywhere. We can see this even on the segment of an orange. The distance between the meridians is the maximum on the equator and goes on reducing towards the poles. At the poles, it is 0. The distance between any two adjacent parallels is 111 km on the surface of the Earth. The distance between two adjacent meridians is also 111 kilometers on the equator. To locate the places within this distance of 111 km exactly, we need to divide the unit degree into smaller units. Degrees are divided into minutes and minutes into seconds. Conventionally, latitudes and longitudes are expressed into degrees, minutes, and seconds. Each degree is divided into 60 minutes and a minute into 60 seconds. These values are expressed using the symbols degrees, minutes, seconds. We can draw 360 meridians each at a distance of 1 degree. 0 degree prime meridian, 180 degree meridian, 1 degree east to 179 degree east meridians. Thus, we have 179 meridians in the eastern hemisphere, 1 degree west to 179 degree west meridians, thus 179 meridians in the western hemisphere. The graticule. The parallels and meridians on the globe form a net that is called a graticule. This facilitates determining the location of a place. Thus, we use latitude and longitude for determining the locations on the Earth. This method is being used even in today's modern age quite effectively. Geographical Information System, GIS, Global Positioning System, GPS, as also Google Maps, Wikimapia, and Bhuvan of ISRO on the internet also make use of latitudes and longitudes. This technology is also available on mobile phones and motor cars. Now, Indian Regional Positioning System. India has achieved self-reliance in global positioning technology with the help of IRNSS, Indian Regional Navigation Satellite System. Locating any place in the Indian subcontinent is going to be easy. For this, India is launching its own series of 7 satellites. It will then be possible to locate any place in the region of South Asia and the Indian Ocean precisely.